Okay, what's up, class? This is kind of a review of what we're going to go over in class, what we would over in class on introduction to programming and different if statements and different type of loops. And I'm going over the examples we did in class together or in your groups here in this video. And then I think as we go along, I'll make videos for all the other problems in tutorial 5, tutorial 6, so you have that to look back on. I'm going to obviously make you try on your own first. Okay, so first thing is if statements. This is the decision, and then if condition is false, there's no else in the situation, so there's no else. But if it's true, you do this process. If it's false, it just goes around and goes and does nothing. This is else, which is used more often. So if it's true, it does this process. Else, so if it's false, it does this process. Okay, nested if statements, which we use a lot. So true, this, else, it goes to this other if statement, true, this statement, and then to the end, else, it goes to this other if. True statement and else, false, it goes to this other statement and then to the end. So you do as many as those as you want, would become very useful. Okay, so the first thing we did after the football one was draw a flowchart and then write the code for a program that has users input the radius of a circle. The program will then calculate the circle's area, circumference, and radius. It will only output the circle's area, circumference, and radius, so it will only output these answers if the area is greater than 20. So that's where the if statement comes in. Otherwise, it will output an error, so that's an if else. So if true, area is greater than 20, then it outputs radius, area, and circumference. And then if not true, if it's less than or equal to 20, it outputs an error, so that's the else. Okay, this is our flow chart. Put this one over and put r user area equals pi times r squared, circumference equals 2 times pi r. Okay, and then it goes to if this area that was calculated is greater than 20 based on user's input. If it's true, then it outputs all of the r area and circumference, and if not, it outputs an error. So let's go into MATLAB and mess around with this. Okay, so I think the first thing is getting the input. So r equals input. Please input radius of circle. Okay, so that's the first line of code. Just press that. Okay, and then based on that, area equals pi times r squared. Okay, circumference equals 2 times pi times r. Okay. Type. Wow. Okay, so now we have those, we've got to go into our if statement, okay? And you're like, oh man, I forgot how to do an if statement. Go back to the syntax here, and ours is just a simple if else. So if an expression, which in our case is a greater than 20, and then if it's true, it is else, so if it's less than or equal to 20, then it does something else. Okay? So let's see. Oops. Go back to MATLAB. Sorry, guys. Okay. So if a greater than 20. Okay, and then gotta make sure you have everything right. Okay, so then a is greater than 20. F print f. We're gonna do f print f. Okay. Because we're out print numbers r is equal to percent okay, and then I'm going to backslash n, new line, and say a is equal to, I'm going to say unit, okay, equal percent to f unit squared, okay, and then backslash n, c equals percent to f, okay. Well, I didn't specify, I'm just being like that, okay, and then I put the inputs r, a, c, so remember, okay, these are the holding places, so r is inputted here, okay, a is inputted here, and c is inputted here, yeah, Then we gotta do else. Okay, and then we don't need to put a decision there because it's whatever is after. I mean, if this is false, then it goes down here. So there's no other condition needed or decision needed to be made. Okay, so then display, and because there's no actual variables being plugged in, we can just plug it in. Display error. Please input a larger area. Okay, and now I ended the code. Okay, so now we run it. So this doesn't matter because their outputs are big. Okay, let's save it and so then we want to run it, obviously. So this worked. Please enter. Or you can put a radius of circle 3. Cool. And because it was greater than 28, it worked. So let's try again. Program 1. Cool. It's going to be less than 20. Obviously 1. Error. Please input. Cool. I have to make this a little prettier. I'll have to put a colon here, space. Okay. And then obviously, there you go. Does that really matter? Not really, but program 1. There we go. 3. Bam. Awesome. Sweet. Okay. So, once again, the key here is the if, and this thing is just area greater than 20, and if it's not true, it does that, displays error. If it is true, it does this fprintf. Okay. So another key, just to remember, is you need the end here. Okay. And no suppressing these outputs. This part. Okay. Cool. Okay, so now we're going to make this a little more complicated. In your root draw flowchart, and then write the code for a program that cycles 10 times. Yeah. So this is going to introduce a for loop for us. Each cycle has a user input the radius of a circle. The program will then calculate the circle's area, circumference, and radius. Okay. For every cycle, it will only put outputs. It's the same exact program, except it's run 10 times, no matter what. Okay. It will no need to output an error this time. It just only needs to input. Okay. So we're just going to take this code, copy and paste it, and then add on. Okay. Now let's go to the flowchart just so we're making sure we do this. Okay, still have the inputs. Okay. This n equals 0 is a new thing. And that's counting. Cool, so that's a counter. So it's counting how many errors you have, which is pretty cool, and it outputs that. Okay, did it ask to do that? Yeah, and these count how many cycles have since it was have an error less than 20. So that's what the n is for. So n has a start at 0 for a counter. Okay, and then every time it goes through this if statement and it's false, it adds 1 to it. So n would be 1 after 1 false. 2, 3. That might not make sense, but as we go through it, it might make more sense. Okay, j from 1 to 10 by 1. So j just is a counter. So it starts at 1, 2, 3, 4, 5. J is not used at all. Sometimes it is, depending on the program. But in this case, once j is creating a vector of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And every time it goes through the loop, it goes to the next place in the vector. And once it's at the end, then the loop is done. Okay, so we'll kind of go through this, see if it makes sense. Okay, so the only input I need to have is n equal to 0. And that's not a user input. That's just me inputting. Okay, so this is still here. Okay, but I need to do a for loop. I'm going to create j equals, I'm creating a vector 1 spaced by 1 to 10. So once again, what that does is it creates a vector from 1 to 10 with a spacing of 1. So it creates 10 numbers, and it allows you to cycle through 10 times. Okay, j1 to 10. Okay, let's go back to our flow. It's okay to do this. Oh, one thing I do have wrong is all of this needs to be farther down. Like, you have the user input, and then you calculate. Okay? Because they're inputting each loop. Now, that being said, it's good to make them 0. This isn't necessary, but it's good practice. You'll see lots of mistakes later on if you do this. Okay? So it's just rewriting those variables we have, but it's creating them and rewriting. Okay, so blah blah blah. Okay, and then the else, we're not displaying every time, so we're just adding on to n. So n equals n plus 1. So once again, first time you add 1 or input 1 for r, then it's going to be an error, or it's going to go to the else, and it's going to become 0 plus 1, and it's going to be equal to 1. So the next time it comes through, if it's an error again, then it's n is equal to 1 before that, so it's 1 plus 1, now n equal to 2. So it's just a way to count, and you use that in almost every code you write, program you write. Okay? So then, last thing you need to do is display. Let's do F. Yeah, and the for loop. Got to do that. F. Now, save it as program 2. Okay. And I'm going to go down here and program 2. Bam. Please input arrays. Circle 2. Please okay. I'll keep going. So I had 2 errors. The 2 and the 1 were my errors. Everything else output. So that worked. The one thing I didn't do is start a new line. I hate when that happens. So the new line now was there, which is no good. Okay. And just to show you how this doesn't really matter, if I do 1 for 20 with the spacing of 2, it would be the exact same program because you have a vector with 10 spots. And that's all you need. Once again, some programs you'll actually be using that variable j, but this one you're not. So program 2. I'm just going to plug in 1 every time. Errors. So once again, it just cycled through 10 times because that vector had 10 places. Now if I change this to 10, it would only cycle through 5 times. So let's do that real quick. Program 2. 1, 2, 3, 4, 5. 4 errors cycled 5 times. Cool. Okay. I was going to try to get this last one in with the while loop. Let's see if we can get it in. Okay, so the last one, okay. And a while executes over and over again until a condition is unsatisfied. So while I is greater than 5, this will keep going and going and going until I, which is reducing each time through the loop, by 1 is less than 5, equal to 5. Okay, so this is the same thing. It works over and over again unless the user inputs 0 for the radius, and that's kind of an exit. So it's like kind of like I want to exit this program, enter 0. So you can tell the user that. Okay. So we're going to update this code. So go untitled program 2. Oh, I only have 1:30. Can I get it done? Okay, go to untitled 4. Okay. Okay. And so instead of doing a while, before we do a while, okay, we're going to say, let's go to a flowchart because they made a flowchart for us. R. Nope. Yeah, while r is greater than 0, because that's the input, obviously. So once again, while r is greater than 0. Okay, and this is r equal to input again, please. Input raise circle. Okay, and that's the input the first time, which is gonna be confusing, but then they're gonna, if r is greater than 0, it runs through this. Okay, calculates A, calculates C, A is going to run it, else that. But before it goes back into the loop again, you need a new R, right? Because to go back through here, you need a new R. So you're going to have another input here. Please input raise over here. Okay, so that's basically everything. So once again, the key here, R equals input. Let's try to run it real quick because I have 20 seconds. I need to get not the free trial anymore. Save. Ready, program 3, 2, 3, 0. You have one area. So the x